This is for ME106, Introduction to Mechatronics, and I'm Andrew.
I'm Jamil, and this is Hugo.
I'm David, and this is the standing assist wheelchair. This project utilizes mechatronic concepts to automate the movement and function of a mechanism through the use of Arduino microcontroller, electric linear actuators, a relay board, a Nintendo Wii nunchuck, and a 12-volt battery. The design objectives were to create a lifting mechanism integrated with a wheelchair to help the user stand up and get out of the chair. The system must sustain the weight of a 300-pound individual. It utilizes 3 linear actuators to raise the seat vertically and tilt the seat using a 12-volt power source. The speed of the vertical translation should be about 2 inches per second within 10 seconds, and the seat bottom's actuator speed should be about 0.4 inches per second within 20 seconds.
So our wheelchair project has 2 mirroring 6-bar mechanisms where they are mirrored to each other. There are 6 contact points, 1, 2, 3, 4, 5, 6. The sliding component of the 2 6-bar mechanisms are to regulate the maximum extension and contraction of the mechanism. There's also a tilting mechanism for the seat bottom, and that's in order to help an elderly person get outside of a chair on their own.
The movement of this assembly is powered by 3 linear actuators. We have 2 on the 6-bar mechanisms here and 1 actuating the tilt of the chair. These are all powered using a 12-volt battery, which is here, and it is controlled using a relay board that is interfaced with an Arduino microcontroller that takes input from this Wii nunchuck controller. We've programmed it so the joystick actuates the raising and lowering of the seat, and the buttons on the front end actuate the tilt of the seat. The Arduino takes input from the controller and activates the switches on the relay board. Depending on which input is actuated, if the joystick is pushed up, then the first and third relays actuate, which tell the actuators to extend. And when the joystick is pushed down, the second and fourth relays actuate and lower the seat. And the buttons turn on respective switches to tilt or flatten the seat. And these wires are all wired to either the positive terminal or the ground bus here. And we have 3 5-amp fuses in series with the positive terminal. So we also take feedback from the actuator's internal potentiometer sensor, which feeds back the position of the linear actuator, and once the slide has reached its maximum position, then the actuators are shut off and can no longer extend. To interface the actuators with the 6-part mechanisms, we've machined these brackets out of aluminum, and part of the design process was 3D printing these brackets first and then testing the interface to see if it was the proper dimensions for utilizing that design. After we configured it to the correct dimensions, we machined these brackets out of aluminum. And there's also a bracket up here for the tilting actuator. 3D printing was also utilized to print these holders for the circuit components. Here's the 3D printed brackets that we use to prototype the actual brackets.
So our project addresses the issue of elderly people's limited mobility and not having enough upper body strength or assistance available to stand up from a seated position to conduct major daily activities. So our solution to this problem is the standing assist wheelchair which incorporates two separate mechanisms, vertical translation and a tilting mechanism, catering to elderly people's need to get in and out of their wheelchair independently while having complete control over height adjustments and preference correlating to their comfort, safety, and height.